Hi, I'm Beren, and I'm a senior solution architect at Confluent, and I'm here to talk to you about what does it mean Kafka at scale. What does it mean understanding latency, performance, etc. Right now, yeah. As I said, work professional services team at Confluent. This means I work with many customers of many sizes, small, big, more complex, less complex, and I make sure that Kafka is used properly, successfully, etc. I used to be I'm working in computers since the year 2000. It's been already a long time. I've been always interested in all things programming, security, performance. This is the kind of things that I like. When I'm not working, you can find me enjoying handball. That's kind of a sport we use a lot or we do a lot in Europe, or playing Lego, or with my kids. Yeah, and that's where you find me. But that's the boring part. Let's jump into the funny part of the presentation. So what we're going to do today, we are going to cover a model to understand latency in Apache Kafka, and their trade-off. Because Kafka is a very distributed system that can be really sometimes complex to understand. We are gonna see a way to effectively measure latency and to effectively measure the way that things are measured and taken into account. And then we are gonna think a little bit about what do you do as a user to optimize the performance or the bottlenecks that we might have. So a little bit of tales of Kafka latency. Measuring performance and latency in distributed systems is not easy. If you have been doing distributed systems for a while, you will notice that the beginning everything looks magic, but then understanding the details is not so easy. In a case of Apache Kafka, what are the most interesting things is durability. Basically, data is not lost. Availability, I still can write and read from data. Throughput, how fast I'm able to do that. And for sure, latency. But latency has many moving parts to understand. There is different kind of latencies in Kafka. As I meant, Kafka is very distributed. So we have producers, consumers, we have the same broker, etc. There could be different times for this latency. The first one is the time to produce. So the time that until before someone calls, so after someone calls to send, until this message is actually sent into Kafka. Yeah. The other latency is the publish latency, the publish time. So it's the time to send these records from the producer into the broker. Yeah, and appending this record into the log. Yeah. So we have had produce time between send, batching and sending, publish time, time to send into Kafka and actually being attached into broker. Time to commit is the next one. It's the time to actually replicate this data. Remember that in Kafka, you cannot treat anything that's not committed. It means it's not being replicated to other followers. Yeah. Catch-up time is the time for the system to offset this log, to record this offset log. And fetch time is the time for a consumer to read that data. If we sum up all of them, this is going to be the end-to-end latency. That basically is going to tell us from between producer and so between write and between read, what's the end-to-end. As a business, as a user, I care about this one. If I'm only measuring produce latency or produce and publish or produce, publish and commit, I might have different sense of this, what latency means. One very common pitfall in this way is using acknowledge. Acknowledge 0 will means fire and forget, only produce time. Acknowledge 1, produce and publish, because I'm actually sending the data and waiting for the reader replica to respond. Or acknowledge all will include all produce latency, all time to write. Yeah. It's very important when we measure latency that we are actually careful of this measure. Understanding produce time. As I said, produce time is the time to produce this record. So the send until request. is actually sending to Kafka. What are the important variables here? Is the batch size, so how big are my batches? The linked MS. Linked MS is this property that sometimes is a little bit misunderstood. It's the time to wait before sending the data in case of batch not being complete. Could be cases where producer is actually slow for any reason, yeah, and we want to delay that. It's well known that for improving performance, you might want to add a little bit of linker. This little bit of linker is going to add a little bit of latency. However, it's going to make faster and better batches. For sure, byte size should be adapted as well in the case of improving the usage. Nevertheless, consider compression. It's probably one not like well known or well utilized sometimes, especially in the customers I work with. But using compressions can be much better in terms of latency and performance. Why? Because much data travels from the pipe. Very easy. In Kafka, the laws of physics are there for us, and we cannot really change them. As well, another variable that's going to be interesting for the performance and latency of produce time is going to be max in-flight requests per connection. This is the variable that controls how many requests are traveling at the same time. Yeah? If there are 5 requests at the same time, it means more utilization of network. If it's only 1, it's going to be much smaller. So by default, keep always this in mind. Kafka is optimized for latency. Yeah, the producer, sorry, is optimized for latency. As mentioned, remember batching it will improve throughput, but at the change of adding a little bit of artificial delay. Nothing else than that. Make use of compression, please. Make use of compression. This is going to help you a ton. You have to select which compression algorithm to use, but it's going to help you a ton. Another attribute to know is the publish time. This is the time between the send and the data is actually append to the leader log. Yeah, this time will include network and I/O processing because we have to, the message will have to fly the batch of messages, and will include time inside the request and response queue. If the load is low, most of the time is going to be used by network and I/O. Yeah? So make sure when you measure that you actually take a look at both of them. When the load of the broker is much bigger, the queue time is what's going to take more of this latency. Why? Because actually I'm going to have more time, more message coming in, and there's going to be back pressure in these queues. It's going to be very interesting to tune this data, these variables, the number of threads in I/O, the number of threads in network, in order to optimize that the queue time is reduced. For sure, all these metrics are monitorable, so it's easy for us to understand. Another important topic to understand for latency is the commit time. The consumers will only be able to read messages that are committed, and committed means replicated to all in sync replicas. Yeah. Important metrics or configuration variables to understand this are actually how fast I'm replicated. They don't have to be changed in most of cases, especially if you are staying with below 1 megabyte in Kafka. However, if you change these things or you actually notice lag and funny network behavior, you want to basically tune these two configuration variables, and they would actually mean the mean number of bytes before actually doing a replication and the time that it will wait the maximum before actually doing a request for replication. These two, like always in Kafka, based in size or time, they will allow us to optimize a little bit. Sorry, as mentioned, sorry, little bit of water for talking. As mentioned, commit time is this time to actually replicate everything. If we detect that commit time is slower, it's gonna mean that it's gonna be that as slow as the slowest of the replicas. So if we want to optimize somewhere, we need to go and see which one of the replicas is the slowest one. Yeah. As everything in Kafka, the default configuration is optimized for latency. So it's optimized for replicating as fast as possible and as quick as possible. If something is happening at commit time, it's going to be because of replication factor. It's going to be because of many things willing to replicate at the same time, and because of load. When these things happen, there is two ways of controlling this. One is basically through reducing load, and another one is basically through improving the capability of handling this load. So now we finish like the time of writing. We want to go to the time of reading. Yeah, fetch time is the time that it takes for a record to actually come from log into a consumer. And like in the replication, we have these two variables, fetch min byte and fetch write max millisecond. They're both usually not have to be changed, but if you notice delay on this fetch time part, this is what is going to help you. And it's going to help you by waiting until a given size, or giving actually a delay on how much to wait. Yeah? And remember, the default configuration is gone for latency, that it's fetching as fast as possible. We have seen a lot of different options or configurations around what each part of the latency pipeline means. However, it's what I like to call the distributed system fallacy, or Mr. Yoda trying to think what the hell is happening. Common misconceptions in latency or trade-off are the misunderstanding of the acknowledge. So usually having a lower level of acknowledge, like acknowledge 1 or acknowledge 0, please don't use acknowledge 0 unless your data is really not important at all. Understand, acknowledge 0 is fire and forget, only produce time. No, acknowledge 1 is publish, produce and publish time, yeah? Because it's literal knowledge. And acknowledge all includes replication, so it will have produce, publish, and commit time, yeah? When we understand only consumer latency, this will only be fetch time, so only that time to read from log. And as a user, as a customer of this Kafka, only thing I want is end-to-end latency. How quick I'm reading from the log, in function of how fast someone is reading. Common problems that happens in terms of latency in these scenarios are head of line blocking, yeah, basically occasioned by large requests coming in. It's very common when you model everything for 10Ks, but suddenly a lot of requests come nearly to the 1 megabyte, or you increase limits and everything comes bigger, yeah. And another common problem is microbursting. So when a large number of low rate request comes in, but they come very often, yeah? And this can cause overload on asking for metadata request. As you know, like Kafka producers and consumers will ask for metadata to know where everything is. So this this low rate overload metadata request, they can be really, really terrible for a cluster. All of this will be very much help with implementing quotas. And for end-to-end latency, it's important that all phases involved in the system keep up. If I'm producing very fast but reading very slow, or replicating very slow, we are gonna have trouble. Oops. Now, and we spoke about anything that can happen. What is now very interesting after talking what can happen is what can I do about it? So, durability versus latency. If you actually know from Berlin, this is one of the biggest lines that happen. It's not the biggest one because it's M29, but M19 is quite big as well. So there is usually quite a lot of latency in this bus. Durability in Kafka is achieved through replication. More durability means bigger replication factor. And more replication factor means more load for broker. If everything is evenly distributed, like it should be, everything should be nice, and every broker should get a proportional bandwidth. However, in order to ensure that, the best way is, or sure, no problem, yeah, in this case is to ensure, minimize the impact, is to always have distributed brokers. So Kafka loves to have everything distributed evenly. Have same number of partitions, same number of leader replicas, same number of everything. And if a broker is highly utilized in network or CPU, I really suggest you to take a look at keep 100C and 3, sorry, 103, and you can have a separate listener for replication. Yeah. So we have one listener for controller, one listener for normal request, for controller request, one listener for normal request, and one listener for replication. So we get actually a much better usage of network. Yeah. And another common solution for this kind of problems on latency is to increase the parallelism, so to put more threads. Based on my experience, think always about this order: evenly distributed, implementing separate listeners, and last case is put more threads. Usually common people put a lot of threads, and then other problems are not solved. Yeah, so this is what is helpful for latency. Oops. Acknowledge. If the brokers are slower giving acknowledge back, it usually decreases the producing throughput. Yeah? So this means that it will increase waiting time, because until I don't get acknowledge, I cannot continue. If we use acknowledge all, it means usually means increasing number of producers. When we configure min-in-sync replicas, it's important for availability, but it's a trade-off. Yeah, so it is trade-off for latency, as replication will happen for all in-sync replicas. Yeah, so one misconception that happens a lot of times is people configure min-in-sync replicas and think, okay, it's going to be good for latency because only 2 replicas are going to be replicated before acknowledge. No, that's false. For replication, in case of affecting latency, is going to wait for all replicas. Yeah, so we can have 5 replicas and min-in-sync replicas 2, and if the 5 are in the in-sync replica list, it's going to go for all for commit time. Another important topic is throughput versus latency. Yeah, this is the eternal question of Kafka: throughput versus latency. As I said, this is distributed systems, is laws of physics, so we really cannot change a lot. Optimizing for throughput in Kafka means batching. So bigger batches and introducing a smaller, bigger delay, smaller artificial delays in order to actually have more data to send through the pipe. However, at some point, the increase of artificial delays might exceed the wins in latency you might get from batching. You have to find like a good balance. Magic number doesn't exist. If your latency or throughput objective are not met, you can buy yourself more by expanding your cluster, because you will get more different machine, move some partitions there, and then be able to utilize this. So yeah, and all of these configurations will be done at the consumer or producer level. So not really at the Kafka level. If you want to improve batching without artificial delays, the application, so when applications produce messages, they are not sent to the same partition, it will affect batching. So it's better to make applications aware of which key to use. Yeah, if it's not possible in Apache Kafka 2.4, there is the usage of a sticky partitioner that really improve latency and performance by sticking to a given partition until a whole batch is full. Yeah. One common question that people might have is, what about the number of clients? So more clients generally means more load for brokers, even if the throughput remains, because there is going to be more metadata requests and more connections to handle. And more clients will impact always on their latency. As well, more clients will increase the number of produce and fetch requests sent to Kafka broker at a time, which means more load. Last but not least, more partitions, please. That's a usual scalability thing in Kafka. More partitions. What can go wrong? Partitions always are the unit of scalability in Kafka. However, too many partitions can have a negative impact on latency. More partitions could mean worse batching, more overhead for replication and bigger metadata requests, larger commit times, and increased CPU load. So please, whenever you think about having 80 partitions in Kafka, control what you are going to do. You might increase latency without the intention. And this will for sure increase the end-to-end latency, including the ones using the smaller partitions. And that's been me for a quick presentation on latency and performance in Kafka. Thank you very much for being here. It's been really a pleasure.